Sorry, I haven't started the recording, so I just started now. S- And this name node contains all this information, and that is called a metadata about the data, right? So you have a data, okay, about this file, and you can have n number of files. I can have another file, okay, which is called foo.txt, and then again I can have another file which is called hadoop.txt, right? So all of these files, okay, will first be divided into the blocks, and these blocks would be stored into one of the directory structure or one of the computers and within the directory. Okay, let me take another. Okay, so the third file is available over here. Okay, so this computer what we are talking about, so this computer what we are talking about, which is containing the information about these files and where these files are located and where is this replication factor and so on and so forth, okay, that is a very high end system, okay, and is a very high end system, okay, and all the information is put into a RAM. Okay, so very important, guys. This metadata information is put into the RAM, whereas the data itself might be stored into your hard disk. So wherever you're wherever you want to store this block, that might be stored into your hard disk. Are you guys with me till now? Or you want me to repeat something? So now you are you all able to hear me? So there was some hiccups. Okay, fine. So see, as part of this session, what we are trying to cover, we will try to go into some of the architectural aspect, okay, of Hadoop, and I wanted to really go into the hands-on in this session, but you guys have not installed the virtual machine, okay, apart from Ashwini. So we have to, we can't do lot of hands-on today. We'll try to just start the cluster. How do I log in and work on with the cluster? Okay, so basically just I would like to start the cluster and show it to you. The third thing which we'll be planning to cover is the testing. Okay, so most of the testing projects into Hadoop can fall into uh, predominantly can fall into the four categories. So we'll be talking about those four categories. Okay. So we'll be talking about those four different type of testing projects. Okay. So just a quick recap of what I have covered. So I said, so if I have a files like this, okay, this files will first get divided into the blocks, right? And this blocks would be stored into a system or a computer, and those computers are all called data nodes. So I'm showing you these are the four data nodes, right? Somehow I need to recreate the information about how do I recreate from the blocks, and that information would be available into my name node. Okay, and name node is another system. Okay, for our simplicity we have covered it as another system, though we can have everything on a single machine. Okay, so you can have name node, data node, everything running on a single machine. So these are nothing but a program. Okay, so let's go ahead and see. So as I mentioned, Hadoop storage approach. Okay, so yesterday we discussed about the problem space, and today we are talking about how Hadoop is solving the problem. First is the distributed data. Distributed data, when data is stored. So when you are storing this data, it gets distributed across the multiple nodes and get stored. Okay. Data is replicated in advance. So one of you asked me what happens if this machine goes down, right? So as I mentioned, the data would be replicated. Okay. So the blocks would be replicated across the machine. Okay. The default replication is 3, though you can configure it to a higher number also, right? And the second is the processing approach, right? So how does a data get processed into the Hadoop cluster? Okay. So since we know, if you have a data and data is divided into a multiple nodes, okay, or multiple systems. So this is my file, and this file is divided into 4 parts, and it is stored over here. Okay. Now, how does the Hadoop takes care to understand whether how to process this file, how do you store the results, and so on and so forth, right? So very first thing, the processing approach is storage and processing is co-located, right? So if you have a data which is available on this machine, okay, your processing will also happen on the same node. Okay, so this is a shift from the distributed computing where you have to move all the data to a central storage for the processing. Okay, and there is a master program that manages the task, right? So what will happen if the processing get failed, if this machine goes down during the processing, and so on and so forth, right? How do you concatenate or aggregate the results from a different machines, right? So this all is taken care by a program called master. Okay, so say for example I have a typical program. Okay, that program counts the number of words into this file. Okay, so we will call this as a word count program, right? So this word count program, what it will do, it is a Java program. It will count the number of words into the program and show me. So if it takes a part of a file and it says in this part, okay, the very first part, I'll try to take it as a color. Okay, so in this part of the file there are couple of words like is coming 100 times, was again coming 200 times, sorry, 200 times, right? So this is like from the first part of the data, right? Or where what data is stored into this machine, right? From the second part of the machine, okay, or the second part of the data which gets processed, okay, we again found out from this part the value, the word is came 10 times, okay, the word Hadoop came 15 times, and so on and so forth. Okay, and similarly the data which get processed by this program word count over here, okay, it is emitting an output something like this, was coming 10 times, okay, and big data coming 100 times, okay, and big data testing coming 1000 times, okay, right. So let's limit it to only these three blocks, okay. And then what will happen if you have a output, because your program is running on all these nodes, it will emit this kind of output, okay, and this will emit this kind of output. Now if I have to ask you what is the count of word is into the entire file, I cannot say based on a part of data which gets processed, okay. So there has to be certain aggregation that will happen, and this aggregation will be based on a certain key value, okay. The key is and the value is 100, okay, the key is and the value is 10, and so on and so forth, right. So it will give me the final output saying that this word came so and so number of time, right. So is came total 110 times, right. And similarly big data testing came 1000 times because it's not appearing in any other part of the file, okay. We will talk in more detail about this program, okay. This is just to give you a representation of what will happen when you run a Java program, okay, or which we call as a map reduce program precisely into the Hadoop cluster, okay. So are you guys fine with me? As you mentioned, name node is a text file or something else, okay, right. So Thomas, name node, just hold on to this question. What is a name node? Okay. Uh, it is not a text file. Okay. Though it stores the information in some file. Okay. But name node itself is a Java program. Okay. And that I will show you in some time. Okay. Okay. Fine. So any questions on the Hadoop processing approach? So yeah, so block size is configurable, not programmable, Rajan. You can configure it. Okay. How does the processing happens for a word count program? I will just hold on to this question because in it would be this is not the logical juncture where I would answer this question. You have to Srinivas, you have to hold on this question for some time. Thank you. Okay. Fine. So let's proceed. Okay. So typically, when you go into any interview sort of things, you will be asked about the characteristics of a Hadoop, okay, and certain conceptual thing about the Hadoop, okay. So let's come to the characteristics of the Hadoop, okay, and that we will try to understand over here. Okay? So when I say Hadoop is reliable, fault tolerant, economical, scalable, and so on and so forth, right? So what does that mean? So as the very first thing what we have seen that this is my name node, okay, and these are multiple data nodes, okay, and name node will have the information about what file is available over here and so on and so forth, right. So say for example I have a very huge file, okay, and the total capacity for each of this machine is, I will say it is the storage capacity which we are talking about is 500 GB, okay, again this is a 500 GB, okay, and this is a again, Am I still audible? Am I audible? Am I audible to all of you? Okay, fine. So, so as I was mentioning it, okay, so I have this three systems, okay. This is my first data node, this is my second data node, and this is my third data node. And I have, in each of the data node, I have 500 GB of disk space, right? So now, for example, I need to store a file which is a 2 TB file, okay. How do I go about storing it into this three system, right? It is not possible for me to store into this three system, okay, because the highest capacity is 1.5 TB. Even if I have to divide a 2 TB file, it will not be stored, okay. So what I need to do, I can add another system into this cluster, okay, and the entire thing is called a cluster. So the number of this is the entire Hadoop cluster, and you can keep on adding multiple data nodes, okay. So what does that mean? That means your solution, Hadoop solution, is a scalable solution. You can scale it from one system or five system. You can go to n number of system. Okay. So it is a very scalable solution. That is what Hadoop scalability means. Okay. The second characteristics we are talking about is economical, right? So if you see this the systems, right? So if you think each of the system, this can be a very low end machines, right? So it can be, if you see a machine which is there in a cluster, it can be as good as a 4 GB machine, okay, and 500 GB 4 GB RAM and 500 GB hard disk, right? So that is the reason you can have multiple low end machines, okay, that you can add it to the cluster and still not compromise on the performance of the cluster, okay. So that is the reason why we are calling it as a economical, okay. So that is the second aspect, the reliability and the fault tolerant, right? So this goes hand in hand, okay. So your system is reliable. Can you rely on the processing approach? Can you rely on the analysis approach which Hadoop gives and provide you the output, right? Is your solution fault tolerant? What happens, okay, what happens if one of your data node goes down, okay? Are you still able to find the data into some other node, okay? What happen if your name node is down, okay? So we will see this, we have a backup of the name node too, okay, and that backup of a name node is called secondary name node. These are the name node, this is a name node, and this is a data node 1, and so on and so forth. This is data node 2, and so on, okay. So we introduced couple of terminologies like secondary name node, data node, okay, and also we explained you the characteristics of Hadoop, okay. Are you guys with me? Okay, fine. So so let's talk about the ecosystem, okay, and post that we will jump into our cluster, okay. So this ecosystem is very, very important for each one of us, being a tester, okay, or being a developer, or being a software design engineer, test, whatever you wanted to call yourself, okay, we have to understand how the ecosystem works, okay, what are the different components into the ecosystem, right? So in the very first class somebody asked me about the MongoDB, okay, so I don't remember who has asked, but somebody asked about the MongoDB, where what is MongoDB, is Hadoop and MongoDB the same, okay, and there are different questions and all which will, if you are not aware of the ecosystem, you might have a very basic understanding gap uh, into where which solution fits at which layer, okay. It is not important for us to work on all of this, okay. Maybe in a Hadoop project, when which we'll be talking about, okay, in some time, you'll not be working on all of this, okay, you might work on a part of it, okay, or some tools associated with the Hadoop, okay. But it's very important for us to to know what tool provides what capabilities, okay, and what as a tester we need to know in each of these tools, okay. So if you see this the entire system, okay, so we will divide it something like this, okay. This is something which is external, okay. This is the part which is the core Hadoop part, okay, that we will call it as a core Hadoop, okay. And these are the system which sits on top of the Hadoop cluster, okay. So these are the additional tools, okay. So what are this? Let's quickly see that, okay. So we talked about the data, okay, into the Hadoop, right? So I told this is your file, and this file will be divided into five blocks, okay, and that would be stored into your Hadoop, right? So that is called a Hadoop distributed file system, okay. How the file comes, okay? File can be into 1 second, guys. Okay. So file can be coming from any of the external sources. Okay, it can be a OLTP system like a structural database. Okay, it can be a flat file. Okay, it can be a structured, unstructured data. It can be a semi-structured data. It can be a music file. Anything. Okay, so anything can come, can be there available. Okay, which we wanted to bring it to our Hadoop system. Okay, and why do we need to bring the files into the Hadoop system? We would like to do certain kind of analysis into this. Okay, so the way the different files, the way it comes into the Hadoop cluster, okay, is through a different tools which interacts between the Hadoop and the external system. Okay, so those tools are called FLUME, okay, and SQOOP. On the same layer, you have something called Kafka. Okay, so Kafka is another tool which will help you to pull the data and push the data into the HDFS, right? So you have a data available here. Okay, you wanted to move data first to your Hadoop cluster. Okay, so say for example you have a Twitter data and you wanted all the tweets from Obama or from our Prime Minister Narendra Modi. You wanted to bring it to your HDFS, right? So how do you bring those data, right? So you need certain utility, and that utility is called a FLUME, right? So FLUME will bring the data from the external sources, okay, and that will be pushed into the Hadoop cluster. Okay, you need to do certain configuration. So very important thing is that when I show you a arrow, it also means we have to do certain thing on the background. Okay, we have to do a configuration file. Okay, and in certain cases we need to have a connector which will connect to this file, okay, through the Twitter, okay, and basically need to log in. Okay. So we lost for a couple of seconds. So now I think you should be able to hear me out. Okay. Okay. So a question came from Rajan: Is the data from external sources moved, or is there any transformation cleaning which happens before being moved to HDFS? Okay, fine. So Rajan, to move a data from external source to HDFS, we don't do any kind of transformation. Okay, we will just pull the data as it is. We might want to limit the data, so what we can do a certain configuration that I just want the tweets from Mr. Narendra Modi or Mr. Obama. Okay, that is what some filtering mechanism which will be doing it. Okay, we really don't do any kind of transformation. Okay, because Hadoop as such, as I said, right, it's very economical. Okay, you would like to do you like to push anything over here, right? So because you don't have to invest a huge amount for storage, so everything has to be stored without filtering also. Okay, okay, fine. So I was talking about a Flume. Okay, so I said there has to be certain configuration, and then you need to connect towards external sources to get the data into your Hadoop, right? So if you see this picture, so there is something wrong. It is this Flume is a unidirectional utility, so you can only pull the data from outside into the Hadoop. So uh, there is no outlet from Hadoop uh, to external system through Flume. So the direction of the arrow is wrong. Okay, right. So uh, the next is the SQOOP. So you guys clear on the Flume? Again, this is a conceptual thing. Okay, when we go into a detail, we will try to explain you how it works. Okay, so as part of, if you can see over here, okay, so we have a details class which will happen on the Flume, where we'll be talking predominantly about how does the Flume works. Okay, and how do you configure and so on and so forth. Okay, so this is just a basic understanding as of now. Okay, so this is, we have a couple of sessions on the Flume also, right? So this is SQOOP and this is the FLUME. Okay, right. Okay. So other thing is the SQOOP. So SQOOP is basically you have a structured data somewhere. Okay. And this is structured data, you wanted to pull it into the Hadoop file system. This is structured data can be any of the databases, right? It can be a SQL server. It can be a Postgre. Okay. It can be a Teradata. Okay. And it can be Oracle. It can be MySQL, okay, or any relational database management system, okay. And SQOOP will help you to connect to these databases and will import the data into the HDFS file system, okay. And at the same time, if you process certain data into Hadoop, okay, so this is my storage. But if I process certain data into Hadoop through my MapReduce framework, so say for example I pull the data, taking an analogy of a word count, right? So I have this a table structure. I pull all the data from this table, put it into this file system, and through my program, word count program, I evaluated that this is what the word is and this is what the value is. And finally, I wanted to publish that data again to my any of the database, right? So SQOOP can do that, right? So basically what I'm trying to tell you over here is SQOOP is a bidirectional utility, right? So in order to understand this diagram, okay, you have to see, you have to understand that SQOOP is a bidirectional. Yeah. So now you should be able to hear me out. Now are you able to hear me? Okay, fine. So as I was mentioning, SQOOP is a bidirectional utility, and you can put whatever you have available into HDFS file system. Okay, you can put that output into any of these databases. Okay, so this is what FLUME and SQOOP is. Okay, we will not cover Kafka as of now. Okay, but just to give you an idea about the Kafka is a real time where you can pull the data from the external sources, okay, like any structured or unstructured, okay, any structured and the unstructured data, and that may pull it into your HDFS file system. So Vasu, that's perfectly fine. You will have a recording shared, so you can look into the recording also. Okay, fine. So Flume and Kafka does more or less similar task, right? So this is Flume is also real time, whereas Kafka is also real time, though there are certain differences between Flume and Kafka. Okay, that we will not be covering, but probably we might try to build up certain videos and then share it with you later. Okay. The second part, so once you have a data moved, right? So there are multiple ways. We talked about Flume, we talked about SQOOP, okay? And there is a way through Hadoop command, okay? So basically there are commands into the Hadoop, and you can move all the data through your Hadoop command. So if you have a file available into your Unix cluster or Unix machine and you wanted to move that file into the Hadoop, you can as well use the Hadoop commands, okay, and you can move the data into the Hadoop distributed file system. Okay, so there is a command to move a data into Hadoop file system. There are commands to move the data out of file system, Hadoop file system, and put it into the normal file system or a Unix file system. Okay, and the entire thing which I talked about now, okay, is data ingestion. Okay, in terminology of big data, when you are going into a data warehousing and big data testing, this is called a data ingestion layer. Okay, so are you guys clear on the data ingestion layer? Okay. So I will not cover the other part because I'm not getting lot of affirmative answers from anyone. Okay. So what we will try to do now is, okay. How about others? Are you guys clear on the data ingestion or partial clear? Okay, fine. So let's see a very small. Okay, so one I also have a positive and non-positive response. Okay, so let's go ahead and run our cluster. Okay, so this is my cluster, which once you install is it's a, yeah, it's a unidirectional. Kafka is a unidirectional. Okay, so we have this Hadoop. Okay, this is my virtual machine. I would like to start my virtual machine. So what we are going to see is how do I move my data into the HDFS file system. Okay, how do I start my Hadoop? Okay, and how do I move my data into the Hadoop file system. So once you install your Hadoop, you will be able to start it, and then you will see we have installed it on a Ubuntu machine. The username and password is same. Okay, so Wisdom Hadoop and Wisdom Hadoop is the username and the password. You'll get a screen something like this. Okay, what you need to do over here is you just go to a dash home, click on the terminal. Okay, and you can start working with this. Okay, so the very first thing you will do in this machine, okay, you have to start your cluster. Okay, when I say a cluster, I'm talking about a name node, I'm talking about a data node, I'm talking about a secondary name node, right? So we spoke about all of this. Okay, so let's see how do I start that. Okay, the command which I have written is start DFS. DFS stands for distributed file system .sh. So any program you run it in a Unix is with a .sh. Okay, so let's start. So when I start my Hadoop, okay, you see what all is getting started. If you can read the output, what is coming, it is telling me something that name node has started. It's told me the data node has started, and it told me the secondary name node is started. Okay. So somebody was asking what is a name node. Okay, so name node is nothing but a program, a Java program that will run as a bundle or when you start the Hadoop distributed file system. Okay, are you guys now able to correlate with the theory? Okay, fine. So now we have started all these three daemons. How do I check my daemons? I just need to say JPS and you will see what all daemons are running. Okay, so you see this secondary name node is running, name node is running, and data node is running. Okay, so these are three different programs. Okay, and that forms the core of Hadoop distributed file system. Okay, so that is whenever we start a distributed file system, which is nothing but a Hadoop distributed file system, which we have said will start with this. Okay, it will start all those daemons and it will start your cluster. Okay, right. So once your Hadoop is installed, okay, Now the second thing what we will do, we will have a file. Okay, we will create a file. The file what we will call it as, we will call as wisdom.txt, right? So that is the file we will call, we will make in my Hadoop file system. Okay, and sorry, not on the Hadoop file system, but on my local file system. Okay, and I will try to move this file over here. Let me just try to clean up the entire thing. Okay, so the next step what we are going to do, we are creating a file and we will be moving that file into the Hadoop. Okay, and let's see how do we move that. Okay, this file is available into my Hadoop into my local file system. Okay, so now how do I browse my local file system? Okay, so all of you know, might have completed Unix basics. Okay, so if I have to see all my files, have you guys completed Unix basics? Okay, okay, so how do I, okay, perfect. So I can see couple of yes and couple of no. Okay, so let us do one thing. Okay, so let us try to list ls, right? Just ls will list me all the files. Okay, okay, so ls will give me this, and ls minus l, so I got a command from Rajan. Thanks, Rajan. And this will give me detailed information about all the files available, right? So if you see this, this is with ls it was not properly formatted. Okay, with ls minus l we'll get all formatted stuff. Okay, so let us try to create a file. Okay, and how do I create a file? Oh, anyone, how do I create a file? Touch. Okay, so there are number of commands. Yes, touch is one of the command, and there are number of editors also. You can use any of the editor. My favorite editor is nano. Okay, and I will call as wisdom. Okay, I'll say batch 18th Jan. Okay, dot txt, right? So this is the file I'm gonna create now. Okay, and in this file I will start writing all your names. Okay, so I'll start couple of names. Okay, okay, and let's try to save this file. Okay, and how do I read this file? I'll have to say cat, and I can read this file, right? So I have a four persons who are available in this file. Okay, and this file is available into my local file system. I can do ls minus l, and I can just say viz star. Okay, so there are a couple of sorry, so there are a couple of files with this regular expression. Okay, so this is the file which we are interested in, which we have created on so and so date. Okay, on January 20th. Okay, so this file has to be moved into my Hadoop file system. Okay, so how do I browse my Hadoop file system? Okay, anybody who has completed the first, second or third videos, how do I browse my Hadoop file system? So guys, you have to be fast. You have to finish our videos also, right? So in order to browse my Hadoop file system, there are n number of ways. Okay, there are three ways. I'm not going to show all of the three ways. What we will try to show is, we will try to do through this Hadoop, and we will say fs, and then I'll say ls. This is how I browse my Hadoop file system. Okay, so ls command has not changed. Only what I'm telling ls, can you please let us know which are the videos to be watched before each class? Okay, fine. Okay. Yeah, sure. So what we can do, Thomas, it's a very good idea. I can tell you, as I mentioned, the prerequisite videos you should have watched. We'll cover that Unix and Java. But for the Hadoop specifically, I'll tell you post this class. Okay, what would be your assignment for the next class? Okay, and that as assignment you can take it up. Okay. Okay, fine. Right. So when I say Hadoop FSLS, okay, so what does that mean? Okay, so I'm firing the same command ls. Ls will list me all the files, and I'm saying Hadoop FS. So I'm saying list all the files into my Hadoop file system, not on my local file system. Okay, and when I do this, you'll see cannot access. 1 second, guys. Ls. 1 second. Should have no such file. 1 second, ls, and it's asking me to have a path. Okay, so let me give the path also. I'll give the path. Okay, fine. So what I did basically over here is since Hadoop file system, okay, I can also say Hadoop FS. Okay, so how the file systems are basically organized in Unix. Okay, in Unix the file system, if you know the Unix file system, okay, so Unix file system will starts with a root. Okay, and this is my root directory, and under the root directory you can have multiple subfolders. Okay, and within this subfolders again you can have n number of subfolders. Okay, so that is how Unix file system is designed. Okay, and this is my root. Okay, the same is applicable for Hadoop file system also, right? Hadoop will starts from a root. Okay, and what it will do, it will have multiple folders and subfolders within that. Okay, so if you see this, it all starts with a root. Okay, and within the root I can have n number of folders. So let's quickly see if I have something under wisdom. Okay, so now I'm saying list of all the files which are available sorry, under my wisdom folder. Okay, so if you see this if you see this, uh, under the wisdom I have only one folder which is truths raw. Okay, so how do I know it's a folder? Because if I observe this is a directory, and then again you need to understand this is the permissions part. Okay, right? So why do we come here? Because what we wanted to do, we wanted to push a file into my Hadoop file system. Okay, so how do I do that? Okay, so the command to do that is this. Okay, I will show you the command and then we will close on for the session. Okay, so I'll say Hadoop, I'll say file system, I'll say put. Okay, and then what I will say, I need to give the file name. Okay, this is the file I wanted to put, and I wanted to put where? I wanted to put under wisdom. Okay, so this is the directory where I wanted to put my file. Okay, right now I have only one directory, but now this file will be available on that directory. Okay, now if I execute my command, I will see a list of file. Okay, so this file now has been moved into my Hadoop file system. Are you Guys, all with me? Okay. So anyone has any questions or doubts? Because this is the very basics. How do we move a file into the Hadoop? This file is in one of the data nodes. Okay. Yes, Rajan. This is in one of the data node. Correct. Okay. Right. So I think we are on closer of the session for today. Though I would like to cover certain testing projects and what are the different areas of testing, what are the different projects, and what is how we are dividing the testing into multiple type of projects. Okay. Um, but I think the time is a constraint. We will cover it as part of our subsequent class. Okay. And at this point, I'll take around 2 more minutes, 2 to 3 more minutes to. Anybody has any questions, then I will try to answer. There will be an external server, and every time we push the data from external server to Hadoop. Yeah, so basically, Hadoop is a storage, right? So uh, when it is a storage, you have to pull a data, or you have to push a data, right? We have to push a data into the Hadoop. The primary storage will be the external servers. So, to answer you precisely, say for example, okay, so this will give you a more context. Okay, uh, when we are talking about storage, okay, and when we have a different kind of online applications, right? So Hadoop is more for a data analysis, okay, where you store all the data from multiple sources. So say for example, I have a application called Flipkart, okay, and Flipkart itself will have a n number of applications, right? So they might have one retail application, they might have one application for their sales team, and so on and so forth. All of this will have a separate storage, right? So they will have a separate databases. Okay. Yeah, so the voice actually, yeah, fine. So There's a problem with the electricity over here, so it's going and coming back, and I'm running on a UPS. Okay, so I lose my internet connectivity for some time. Okay, so as I was talking, answering the question from Thomas, yes, the storage, because there are different applications, the storage would be on a different application. So right. So if you have a different applications, which I was talking about, flip, this is my first database, second database, and third database, and the applications are running here. Okay, and finally you wanted to integrate your databases. Okay, that is something where you move all the data into a consolidated location, so that is where the Hadoop comes into the picture. Okay, so it will basically do, you want to move all the data for certain analysis. Okay, does that answer your question, Thomas? This is what we have covered in the yesterday's class also. Okay, so there is another question which does name node decide which data node should the particular block of data be sent? So yes, so name node is like a master program, Rajan. Very correct, because it decides which data nodes are available. We will talk about that in the next class, how it does a decision where to put which data. Okay. Right. So
Hi, Vivek. One question.
yeah, go ahead.
Hey, where can what video do I need to watch to learn on how to install the VM and
Yeah, yeah, sure.
deploy Hadoop
Yeah,
file?
yeah, correct, correct. So let's answer your question. Okay, so one of the question was what are the prerequisite videos we need to watch. Okay, so I'm going over here. So very first video for the next class, what you need to do is how do I deploy my Hadoop. Okay, and once you log in into the course, okay, let me show how do you log in. Okay, with your account. Okay, so this is the video you need to watch. Okay, there is, this link is not very prominent, but just see on very top you have a click here if you want to set up VM for the Hadoop installation. Okay, all of you guys just click on this, it will open up a video link. Okay, and that video is a must, you should watch. How do you install and set up the VM. Okay, and the second video, as a prerequisite from the Hadoop side, I would like you to cover video number 12. Okay, and that will be helpful so that you people could ask lot of questions. Okay, before the next class starts. Okay, so this is the video number 12. Okay, we have detailed about what is name node, data node, and so on and so forth. How do I browse the Hadoop file system? I showed you a one way of browsing it. We have showed three ways of browsing it. Okay, right? Okay. So I think I'm done for today's class. Okay, we will meet for the next class. Okay. Thank you guys for joining the session. Bye bye.
Hi Vivek, one question. Yeah, where can what video do I need to watch to learn on how to install this VM and deploy Hadoop file?